Right, welcome. Welcome to our talk. Thanks for coming. Thanks for taking the time out of your day to come and sit and listen to us talk. And thank you to the organisers at Box Days Belgrade for inviting us to speak today. It's a real pleasure and a real honour, isn't it? Right. We're going to talk about Google Cloud Platform end-to-end, or how we built Cloud Spin. No, nobody's heard of Google Cloud Platform, or nobody's heard of Google Cloud Spin, so we have a lot of education to do. So, introductions first. I am Mandy Waite. I'm a developer advocate for Google Cloud Platform. Thank you. Good point. I always forget that. You can get me on Google Plus, plus Mandy Waite. Who's using Google Plus still? Okay, cool. Keep using Google Plus. You can write longer things on Google Plus. And at TechGirl on Twitter, which is on the back of my t-shirt, if you forget. And that's also on the bottom of the slide as well.
Yeah, sorry, I don't have a t-shirt like you, but I'm Ludovic Champenois, so I'm a software engineer at Google, so I'm in charge of the Java runtime and SDK for App Engine. So even though I'm French, I'm located in the US working with the App Engine team over there. So you can get me on Twitter or Google+, very easily.
Awesome. Okay, so Cloud Spin. We've done a poll. Not many of you have heard of Cloud Spin. So if you go to Twitter, at Google Cloud Spin, you'll find what we've been doing with Cloud Spin. And it's all about getting matrixy in the cloud. How many of you have seen the Matrix? Okay, right, cool. So basically something like this. It started in the middle. Let's start from the beginning. We have the guy, walks out, kung fu kick, 3D picture. Okay, just like in the Matrix where she jumps up and you see her in 3D. It spins around her. We built this as a demonstration application to demonstrate the power and capabilities of Google Cloud Platform. And so that's what we're going to be talking about, how we built this application.
So basically it's a camera, no? It's a camera application.
It's a camera application, yeah. Absolutely, yeah. So we have cameras. You can see them in the background of the image there. Our engineers came up with this design for it. So we have lots of degrees. It's a very technical drawing. Number of feet and meters in Europe. Number of phones, we have 19 phones in a 180-degree arc, 10 degrees between each phone. This is what our engineers came up with, and we gave this to the marketing team, and this is what they came up with, which is probably a little bit better than ours. And this is what it looks like. So we've done this on tour at Google Cloud Platform Next events across the world, and it's been really cool. And basically what the idea is we have 18 smartphones in a half circle. We have a big X on the floor where somebody goes and stands. We have a backdrop, and at some point we told them to jump. They jump in the air, and we take that 3D photograph of them. And if you go to at Google Cloud Spin, you'll see many examples of it. And how does this work? So basically we have this guy, Fred. This is Fred. Meet Fred. Say hi, Fred. So Fred, our customer, our participant, whatever, he walks to the middle of the Cloud Spin area, stands on the X, and somebody on running a tablet application presses a button on the tablet application, and that communicates with the phones to start recording the video. And it also starts a countdown. 3, 2, 1. The countdown begins, and at some point, somebody tells Fred to jump in the air. I won't jump, right? Somebody tells Fred to jump in the air. They press another button on the tablet, and a signal, audio signal, is sent to all of the phones. Audio, right? So we're recording video, and we're using an audio signal to mark the frame on the video which we care about, which is the one we need to extract. And that's what happens. That's how it works. And we have a video of Cloud Spin, and we're going to hopefully see if the audio works here. This is one of our guys, Ray. Oh, work. Ray's stuck. No, he's not moving. Why is he not moving? Ray, why are you not moving? It's strange, right? It's very weird. Maybe our connectivity is broken. Ray, why are you not jumping, man? Come on. I'm going to tell him off. I've made a really bad mistake and reloaded the slides. And at that point, the internet connectivity goes away completely and nothing works.
No, it works.
All right, okay, cool. Let's try again. Present mode. No, it's muted for some reason. Anyway, so basically what's happening here is Ray is in the middle. He's on the X. He has something to throw in the air. And Robert is, no, it won't work. And Robert is going to press the button on the tablet. At some point, we instruct the phones, we send the tone, Ray jumps in the air. Then he walks off to the side to show people what happened. We're not going to look at that. We'll do that ourselves in the demonstration later. So all of this happens in the cloud, effectively. So we have all of our backend stuff in the cloud. 19 phones, they're all talking to the cloud, uploading our stuff. And yeah, that's pretty cool. What else can we do? What else can we do? Our startup idea.
Well, I mean, yeah, we want to scale this product. So we want to be able to create a startup and install this kiosk everywhere. I mean, anywhere in the world, on shopping malls, whatever. So basically, it's not only one little camera that will have to handle the processing. We want to scale to the entire world. So for that, this is why we need scaling system like Google Cloud Platform can provide. So whether it's in the storage area, the processing area, or the pub/sub area.
Okay, so that's a good point. So we want to start up, we want to build this thing, we want to ship it out to different shopping malls and train stations, all those kind of things, and then we'll have lots and lots of images, and we need to scale in the cloud. Otherwise, we could do it all locally, so that's not much fun. So let's do really big and think really big. So our backend architecture starts with uploading these videos that we record on the phones, and then sending off notifications to a pipeline that starts the processing. So the video uploads happen, they go to an input bucket somewhere in the cloud. So we have to store them in the cloud. At some point, these images will be pushed into a processing pipeline. The frame will be extracted from the video, and that will be stored temporarily. And then ultimately, they'll all be stitched together, all 19 images, stitched together and stored in the output bucket. So we need bucket-based storage for videos, for images, and for the final output image. And our specific requirements are storage for large amounts of unstructured data. Also, we want to be able to access that data immediately. As soon as it's uploaded, anybody who wants to read that data should have access to it, so it should be strongly consistent on reads at least, not on lists necessarily. We also want to be able to fire notifications off when anything new arrives in that bucket. So for this, we chose Google Cloud Storage. And Google Cloud Storage is basically an object store, bucket-based storage for pretty much infinite amounts of data, up to terabytes per object, huge objects. All data is encrypted at rest. It has a 99.95% SLA. It's geo-redundant replication, so your data is extremely secure in cloud storage. And we have that requirement of strong read-after-write consistency for every object that's stored. It also supports versioning. It supports resumable uploads. And so for terabytes an object, you probably want to be able to resume. And it also supports change notifications, which is one of our key requirements. So that's perfect. There are 3 options of Google Cloud Storage. The first one is standard storage, very similar to Amazon S3 if you've used that before. It's quite cheap, it's fast, it's available, and it's durable. Very basic storage for everyday work, unstructured data. And then we have DRA, which is our durable reduced availability storage, which has a lower cost point, but also has lower availability. We have less replicas of it. So this is better for where you don't require access to the data absolutely immediately. Like you need it in seconds, not in microseconds or milliseconds. And Nearline is a version of DRA that's effectively half price. It has the same durability as all of the other features. It's a little bit slower, a little bit less available, but it's perfectly suited for use cases where you want to archive data, but you don't want to access data very frequently. So that half price is perfect for when you only want to access the data once a month, no more. Otherwise it becomes more expensive and you should use DRA. So that's Nearline. So object change notifications, we mentioned those. We have a bucket. In this case, we're going to call it My App Input Bucket. And we have an endpoint for doing notification processing. So what happens with this is we use a command line utility called gsutil, it's part of our cloud SDK, to set up a watch on that bucket. So we say gsutil notification watch bucket, we pass in the endpoint name and the bucket name, and we wire them together effectively. So now when a client comes along and adds or updates or removes an image in that bucket, a notification will be fired off to the notification processing endpoint. Okay, simple as that. And the notification looks something like this, HTTPS post request containing metadata about the changes that happened, and that includes the URL of the image. Cloud storage also supports edge caching, so we have points of presence around the world. I'm trying to work out where these ones are. There's probably Bucharest, right? It's very close to Serbia, but it's not close enough. Maybe Bucharest. But we have points of presence around the world, and you have the ability to cache data on the edge of our network just by adding cache control headers to your data when you upload it. So now when it passes through the edge of the network, it reads the cache control headers and it will cache it locally. It's not a guaranteed cache, it's not deterministic, but it will give you better performance for your applications. Particularly if you're in Sydney down here, which is like miles away from anywhere, right? Only people who've been to Australia. I've never been to Australia. It seems like a long, long way away. Have you been to Australia?
No, never.
No. Okay. So basically, we're going to do all of our processing from buckets. We're going to store data in buckets, videos uploaded, images extracted. Our ultimate output file will be stored in cloud storage. And just to play this, did we have audio last time? We didn't, did we?
Nope.
Okay, so this actually, if we had audio here, you'd hear the beep. This is one video. You'll hear the actual noise. I can play that to you later, but it's basically an audio tone that's recorded on the video. And that's how we detect the keyframe. So basically, I'm going to hand over to Ludo now to talk about notification processing.
Yeah, so we've just seen that cloud storage can send notification in the form of a HTTP post request. So now we need a recipient for this post request. So basically, the layer that we are talking about now is this notification processor. And the requirement for this layer in our system is, first of all, it has to handle HTTP post requests, so capable of processing business logic based on HTTP post request. Obviously, it has to be secure. We do not want to trigger our video processing from anywhere in the world. You know, we just want to process it from a well-known endpoint coming from the cloud storage endpoint. So for that, we need very simple, we need authentication layer, and I don't know if you have used auth libraries before in your project. It's rather complicated to set up. So the requirement here is it has to be simple, okay? Secure, but simple as well. And then all this application is doing a lot of video processing and audio processing because we need to find which frame, which picture is correlated with the sound that will get all those pictures together. So we need good process power capable of running things in a queue. So for that, we could have used Google App Engine, for example, to implement this notification processor. So App Engine has been there for a long while. It's one of, this is the first product that created the Google Cloud Platform. It was very simple. Basically, we launched it in maybe 2008 and 2009. And what you could do is write your business application, whether it's in Go, in Java, in Python. Now we have PHP. This year we launched PHP. We are launching also soon Node.js or custom runtimes where you can provide your own container to handle App Engine processing. So the idea is you just build your business application. You test it locally on the SDK. You can download on your laptop. And once you're okay, you deploy your application to the App Engine product. And Google will scale it from 0 if you have no customers to millions if you have many, many customers. One of the biggest applications running today on App Engine is Snapchat. So I don't know if you are using Snapchat here, this phone application where you can send pictures to your friends and they can watch them only for 10 seconds. You deploy your application code, you can use the capability from App Engine where each version, each application you deploy is versioned. So let's say you have a stable version, but you are working on updating your code. You can upload a new version of the same application and use a capability that we call traffic splitting, very easy to set up in the admin console, where you can say, I want to redirect traffic, 10% of my traffic, to the new version, and then I can watch the logs, see if my application, the newer version, is behaving correctly. And when you're okay, then you you move 100% of the traffic to this new application. You can obviously roll back to the previous version if you're not happy with it. So having live multiple versions at the same time of the same application is one of the key aspects of App Engine. So obviously, once you deploy your application, you have nothing else to do. Okay, well, maybe pay a little bit if it's used, but it is completely managed by Google engineers. The same engineers handling internal traffic for Google, because your application is running the same data center as our server serving ads or doing Google search or serving Gmail or serving Google Docs. Your application is running on the same hardware and managed by the same engineers to make it reliable, failover, 24/7 support. Whenever there is an issue somewhere, we do the work for you. So to run this application, we run it in a very secure environment. Why? Because we do not want your business application to see other business application from a competitor or even from the other internal Google services we are providing. So this is why your user code in green here can be written and executed in an environment that we call sandbox. So basically, sandbox is a restricted environment that allows you to do many capabilities, but not everything that you would want to do, for example. In the Java world, for example, we do not allow you to use native code. Okay, GNI, not very secure. Why? Because as soon as you have C++ code, you have memory leaks and issues with that. So this is why we are also now working on a newer version of App Engine where the unit of execution is a container. Okay, so you write the same application using Go, PHP, Node.js, but when you deploy it, we are creating a container and running it inside a VM inside, and the VM is running the container. So this way you have all the power of the new technology called containers. I don't know if you have heard about Docker containers. Who? Yeah? Okay. So here in the Docker container, you have a very nice new sandbox environment, which is much more capable of, than the previous one. So this is called the managed VMs or VM-based hosting environment for App Engine. So in summary, the tier we have been looking at now is using another big product of the Google Cloud, the Google App Engine product. For this application, we use the Go runtime. Why? Because Go is very simple to write and more popular. So next, we'll be talking about what do we do once we want to execute the video processing. Right.
Okay. So. And basically, the guy who wrote most of this is Francis Champenois. He's a Go expert. He's one of our guys who talks about Go all the time. So basically, because we've come up with this startup idea, now we need to do everything asynchronously. We could have just done everything synchronously. We only had to worry about one demo, but now we have many versions of this thing running all around the world. So we have to do things asynchronously. We want to not hold everything up, push things through very quickly, and not have to wait for things to happen. So we're going to be using some messaging and some pipelines here. And messaging, you're probably all very familiar with messaging, JMS, all of these things, WebSphere, MQ, all of this stuff. But just to kind of summarize, two core use cases for messaging. One is availability, the ability to buffer new requests during outages. And when something goes wrong, your requests are coming in, they're not being lost, they're being buffered. Also to be able to prevent the overloads that cause those kind of outages, to stop some activity completely swamping another system. And also the ability to redirect messages when an outage occurs. So you can say, I have messages in this queue, I'm going to push them out somewhere else because the server's down. Also with throughput as well. Throughput is often very patchy and very spiky. You have lots of traffic happening at one time and nothing other times. That can very quickly overwhelm a certain group of servers while they're trying to scale. So this will smooth out your throughput and effectively allow you to balance load across multiple workers so that you can effectively match the arrival rate of your requests to the ability to actually process them. So messaging is really important, and you probably already know that. So we have that problem here. We want to be able to do that. So we want to do everything asynchronously. We have a couple of queues, one to extract or extracting the frames from the videos, another one for stitching them all together. So we have queues of messages. These extraction tasks are going to be pushed to a queue, they're going to be extracted, and the stitching task is going to be pushed to the queue as well. So
again, here we are talking about processing millions of videos on one single system.
Potentially, yeah.
It's not only one kiosk, it's many of them.
Yeah, so we need to be able to scale massively, right, without having to worry about building infrastructure. So our requirements are asynchronous messaging and pull subscriptions. We want to be able to pull stuff. So we're going to be dynamically scaling this. We don't know how many workers we're going to have to actually do the processing work. So we don't want to be able to have to register them for push notifications, push subscriptions. We want to get them to go and pull stuff out themselves from a queue. Probably the last requirement is the ability to scale massively based on our demand, which some mechanisms may not be able to do. So for this, we chose Google Cloud PubSub. This effectively gives us real-time messaging, reliable messaging, many-to-many, asynchronous, and effectively allows us to decouple the sender from the receiver. And again, the scalability here is that you don't need to scale this thing yourself. We will do it for you. So the more messages that come in, we worry about how to handle that capacity behind the scenes. It's not something you need to say, I need to add more capacity to my PubSub. We'll just handle that automatically. And that's not the case with other queuing systems. Also, minimal latency. This is built into the cloud native, built into our infrastructure. It has redundancy built into it, and ultimately the ability to send data from one application via a messaging system to another application that can consume them. Publishers and subscribers, sorry. They work like this. You know how this works. You know how all this stuff works. We have topics, and we have publishers pushing messages to topics. And we have subscriptions on those topics, which consumers, subscribers, can actually subscribe to receive messages from them. And they can do this either pull, they can go and say, I want the messages you have, or they can wait for a push notification to come from the system. And pretty much anything can be a publisher or a subscriber. And for the publisher, Google Cloud Platform applications or third-party cloud platform applications, desktop, mobile applications, even command line applications, browser-based clients can all push topics to the topic, push messages to the topic. And pretty much anything else can be a client. You have to be capable of receiving push subscriptions, but if you're a pull subscription, you can go and retrieve that yourself. So any kind of endpoint can be a push subscription. A pull subscription would have to have some kind of information about the system that it's servicing, maybe a client library of some kind. And we have free use cases. There are free use cases. Anybody know the Spanish Inquisition, Monty Python? No? Okay. There are free use cases. So in this case, we're going to not talk about log ingestion. So we have lots of logging going on here. This is a world-class application. You know, we need to be able to log stuff so we can audit later. So we log in. We have a frame extraction topic. So our App Engine application is pushing messages onto this topic. And we have a bunch of extractor nodes, which Ludo's going to talk about shortly, consuming going and getting messages from this topic. And these will be tasks saying, you have a video, you need to extract a frame. And that's what this would look like. Frames extracted, here's one frame, then we have the other frames as well. So ultimately we'll have 19 frames that we can stitch together. The last one is the stitching topic. In this case, the extractors will be, once they finish, they'll be writing to a topic to say, I've finished. They'll be doing some other stuff as well, which we'll see shortly. And the stitcher will be one stitcher in this case. We're going to have to scale probably later to more than one, but we only have one currently. The stitcher will say, there's a stitch job to be done. I need to do some stuff here. I need to get those images, pull them together, and stitch them all together. And ultimately, once we've finished, we'll have the output image, which looks something like this. So over to Ludo to talk about those processing bits, those stitchers and extractors.
Yeah, so we could have used App Engine because App Engine can allows you to write business logic, but we decided for this end-to-end demo to use another big product for the Google Cloud Platform to implement those business processes. So which requirements do we need for this layer? we need long-running services with on-demand scaling. So long-running service means, doing video encoding, video extraction can usually take a lot of CPU or GPU sometimes. App Engine is very good at handling requests, live requests for web servers, but we have a timeout of 60 seconds by default. We have App Engine modules, backend modules that allow you to do longer processes, but here we wanted to have something capable of doing long-running service. Obviously, we want to be able to consume pub messages as well as post new messages to the queue for, let's say, logging activity. So we need to be part of a pub sub environment. Then, again, as before, we want to be simple to develop, deploy, and manage. So for that, we picked Google Compute Engine, which is basically the capability for you to create VMs in the cloud, hosted anywhere in the world. So we have all the regions covered, the US, Europe, in Asia. All the networking between those VMs is completely virtualized by Google, and those VMs can communicate extremely fast between them or with the outside world. Again, you have the notion of private or public network there on IPs. We don't want it to cost a lot, and here Compute Engine is very good because if you boot a new VM and you use it 11 minutes, you will be billed for 11 minutes, okay? As opposed to 1 hour in other cloud provider, where if you use some CPU power on a VM, you are billed rounded to the hour. Compute Engine is not charging you for bandwidth used for reading and writing storage. We only charge you for the block storage, the size of the storage you are using. And also, we have a capability of load balancing traffic between those different VMs without having you enabling or configuring a load balancer or having to provide the load balancer tier, because the Google load balancer is baked in the Compute Engine platform. Obviously, we want to be able to boot very quickly. So usually, you can boot one VM in less than a minute. But you can also boot 10,000 VMs also in less than a minute, okay? Because they will be sharded across multiple data centers. So these are the different VM types that we offer. On the operating system side, you can pick between Debian, CentOS, SUSE, Red Hat. Recently, Windows Server, we went to GS, so now you can use Windows Server payload if you want. If you are a .NET shop, you can host your traffic on the Compute Engine. And then once you have decided on the VM, you can decide how many cores, CPU cores you want, between 1 up to 32. Again, recently upgraded because I think early this year we were limited at 16 cores. Now it's 32 cores. In terms of memory, 200 gigs of RAM, pretty good for in-memory video processing if you need that. Now creating a VM, everybody can create a VM. The nice part about what we are providing is you can group VMs together based on the template. And this is what we call an instance group, okay? So you define a template, or I want a machine type of 32 cores with 100 gigs of memory using CentOS, for example. So you describe this, and you configure an instance group manager that will be in charge of booting those VMs or destroying those VMs based on some events, okay? But those VMs will share exactly the same characteristics. So the instance group manager is in charge of creating and destroying those VMs based on the template. So once you have this instance group manager and instance group, the next thing you want to do, possibly, is install what we call an Autoscaler so that you can say my group of instances should be able to scale from 1 to, let's say, 100 VMs based on external events. So those external events could be the CPU utilization. So let's say you have one VM using 60% of the CPU. Well, you want to configure the Autoscaler to start a new VM so that at that time you'll have 2 VMs, each consuming 30% of CPU. You can also configure the Autoscaler to listen to external events. So for example, in our case, we configure it to listen to the number of pub/sub topics coming in the pub/sub system. Okay, so this way we can provision more and more workers that will extract and stitch the videos based on the number of kiosks sending, uploading images.
Nice.
So those VMs, well, they are VMs, so Linux operating system most of the time. You can install container technology on top of them. So this is what we did for this example as well. Instead of running native code inside the VM, we wrapped our business logic as a Docker container and using a container VM image, which we provide for you if you want, where you have the entire Docker system and you can run Docker containers. So this way, you have a nice isolation of your business logic. You can even test on your Mac using some developer virtualization system like boot to Docker or VirtualBox. So,
wrap up?
Wrap up?
It's
No?
not wrap up.
No, something's wrong here. No?
Something's wrong. Yeah. What happened there?
A slide
Weird,
dropped.
Okay.
Okay. Yep. So just wanted to show. So we have been using cloud storage here. This logo. You have to start learning those logos. Google App Engine here, and those 2 processing units using Docker containers running in VMs on top of the Google Compute Engine. So what is missing now in this picture is this coordinator, correct?
Coordinator, yeah.
Okay, so what is this red box here over there?
Yep. All right, so basically everything's asynchronous. We've talked about how asynchronous everything is. Ultimately, we have to kind of tie everything back together. We may have many different images being processed simultaneously. And basically, whenever we create a new photograph from one of our kiosks, from our main application, we create a session ID, effectively the picture ID. That's completely unique within the system. And each phone will have its own unique ID within the system, 0 to 18 or 1 to 19, whichever categorization we chose to use. And we can identify which extracted images correspond to a given picture using that. But we need to actually tie everything together. We need to know when the images are completely processed from one picture so that our stitching task can go along and find all of those images and pull them down. So basically, it looks something like this. This is our pipeline from end to end. We have App Engine pushing notifications into the extract queue, the extractors extracting frames from the videos, writing to a stitch queue, the stitch queue picking up the task in the stitch queue and stitching all the frames together. And what happens is that the extractors will write their extracted frame to temporary storage. Again, this is Google Cloud Storage like we talked about before. At the same time, they will write a message to the stitch queue and also write to an online database, so another database in the cloud somewhere. They will say, this image is processed. And the stitcher's job then is to receive that message from the stitch queue. Okay, I have this image. Have I got all of the other images that I care about as well? So we will go to the online database and we will look for that session ID, find all of the frames, and check to see if all of them are ready. If they're not all ready, it will stop and wait for the next one to come along. And ultimately, the extractors, 19 times, will push messages to the stitch queue. When the final one comes along, the stitcher will go along and say, are all my frames ready? And everyone will be ready. And it says, that's great, I can go and get all of the images, and I can stitch them all together. And that's exactly what happens with the coordinator. So the coordinator is the online database, effectively, here. And so our requirements for our coordinator are for it to be cloud-based storage. And we don't want to have to write server-side code. Right? Our application is already complicated enough. We've hired lots of developers. We don't want to have to hire any more to write this back-end application. Okay, so let's keep it simple. And we also want updates to be pushed out to the clients in real time. We have other things like the login mechanisms that are interesting stuff that's happening here. And they need to receive updates in real time. And what we chose for this is Firebase. How many of you have heard of Firebase? Hey, how many of you are using Firebase? Oh, come on. Tomorrow, when I ask this question, you'll be saying, yeah, we're using Firebase now because you told us about it. It's fantastic. So Firebase is a NoSQL JSON store in the cloud. The storage-wise is very, very similar to MongoDB. Structured JSON, nested JSON objects. And one of the differences here is that any updates you make to data, or one client makes some data within Firebase, will be pushed out to anybody else that's interested in those updates immediately, pretty much in real time. So this is a real-time database. The security model effectively allows clients to access the data directly. So we don't need any server-side code to act as our ambassador on behalf of the application. They can go straight to the data. And each data has its own URL. So this is completely RESTful. Every single piece of data within our JSON tree can be accessed via URL. And we'll show that shortly. And demo time. So we have time for a demo, right? Okay, yep. Let's do this. Do you want to show the app engine console?
Yeah, we can. Before the demo, we can look at the admin console.
Yeah, show the app engine.
Basically, we have been talking about a lot of products. I mean, storage, app engine, compute engine, PubSub. So I wanted to show the admin console for managing this project. So it is one single Google Cloud project. Okay, the project is called Cloud Stream Mini EMEA. You can switch between projects here, but we're going to stick with this one. And here I am on the compute, app engine, version tab. Okay, you see that version? You remember I said app engine, you can deploy multiple versions. We use Go here, which is a default version. So this is my running application. But yesterday I pushed a few other versions written in Java with different names. And just to illustrate the capability of traffic splitting, where you can say, 10-12% of my traffic would be, for example, migrated to the QA version of my application. Okay? You just click on save and bang, 12% of your traffic will go to this new version if you want. Okay? Very. So actually you can put kind of application in this case? Yes. Yes, you can. So this is for the App Engine view of the business. Mandy has been talking a lot about PubSub. Here, the last item in this tree is all the topics that have been created by the application that you can also view whether they are push or push. So here she mentioned a log topic doing push, and we have the stitcher doing pull. So again, you can view the endpoints there, very easy to manage. Cloud storage, you can browse the buckets. Okay, so here, they are here. No, the videos will be uploaded here.
Over there. Yeah.
Okay, so we have a timestamp for the video name, and then you have what is uploaded from the phones to the system.
Yeah, that won't be active
okay.
now. So.
And finally, compute engine, showing all the VMs running on the system. So here is one, okay, and you can even click on the SSH button over there to connect to this VM if you want. Okay, so it was just a brief view of the system. Okay, it's not only concept we are talking about; it's real thing that you can manage with this admin console very easily.
Awesome. Okay, right. So let's show you the full demo. There's my window. Where's my other window? Get this window out of the way because we don't need that one. We need these two. So basically, we saw what happens when people click the tablet in the video. We saw what actually happens. Guy jumps up. Guy presses the button just at the same time as he jumps up, and we take the videos, we record the videos, and we record the audio tone. So now we're going to look at this whole process from that point onwards, where the videos have been captured by the phones, 19 phones, and now they're all starting to upload their video data to this cloud storage bucket. On the right-hand side here, we have Firebase. This is the Firebase debugger, and this shows effectively a tree-like view of our JSON object. It's a tree-like structure, nested JSON, and we have some interesting things here. We have the session, which is a session specifically reserved for this demo. So we're going to use this session for this demo. And we also have, for the session, we have individual frames. And we have, believe it or not, only 17 of these. Why have we only got 17? What's happened there? 18, right, okay. Well, it should be 19,
18,
right?
yep.
It should be 19. So the guys keep messing around with this demo. They move from having 18 phones to having 19 phones. Because you need 19 to do 180 degrees. But we have smaller versions of it as well, which we can transport around the world. Not to here, unfortunately, because we're not ready yet. But, so in this case, we have 18 phones. And we also have a placeholder for our output file. This is where our output file will be stored. And over here, we have a representation of the whole pipeline. And we have a box here for each one of the videos that will be uploaded. And I can just copy the videos over to the cloud storage bucket. So just pretend these are 19 phones, or 18 phones in this case, that are uploading their videos to the cloud storage bucket. And I can go to here, which is, again, I've SSH into the virtual machine somewhere that we've set up. And we're going to copy some videos over to a cloud storage bucket. We're going to use gsutil command, which is part of our cloud SDK. gsutil copy -r videos to a cloud storage bucket URL. And that's what that is at the end. So if I hit return on this, and I have to be very quick because it happens quite quickly, and I go to here, and go to here, and I expand this one, you'll see what starts happening. Hopefully, something starts happening. Yep. So now you can see in Firebase over here, we're seeing the yellow, they're changing to yellow, which means they're being updated. For number 5, you'll see that's shortly changed to ready. So now that one's ready. We've uploaded the data immediately. It's immediately reflected in Firebase. And over here, we're seeing the videos being uploaded. So they're quite large videos, actually. We're trying to keep the quality up. So they're like 30-odd megabytes in size each. So we're copying those videos over. And we're probably finished now in terms of all of these. You can just look at them. Yeah, they're all ready. So now the stitcher should be about to say, okay, they're all ready, and it will start stitching them together, and ultimately we stitch together to get our resultant image. And that's how it works. Okay? That's Cloud Spin. Okay, cool. So the next thing is just to kind of introduce Container Engine, and then give you a quick wrap up, and then ask questions. Okay, so nice, okay, right. So Container Engine. How many of you have heard of Kubernetes? Yeah? Hey, how many of you can say Kubernetes? Okay. If you want some help with pronouncing Kubernetes, I'll be around. You can come and ask me for help. Yeah, Kubernetes is hard to say, hard to get right. But basically it's for managing Docker containers. It's something I talk about a lot. If I'd known there had been a slot available yesterday, I would have given my Kubernetes talk, because it was really good. I really enjoy it. But Kubernetes is basically used to orchestrate Docker containers, because once you start having one Docker container, you're going to put everything in a Docker container. Everything, right? So ultimately you end up with lots and lots of Docker containers, and you don't know what to do with them. So for that, we found ourselves in the same problem a long time ago at Google. We had all of these containers. What do we do with them? Well, we schedule them. We basically abstract all of our compute infrastructure out into one big cell, and we push stuff out to it. Our engineers don't have to worry about SSH into machines. They just say, run this for me, and off it goes. Run 10,000 of these for me, off it goes. And Kubernetes does that for us. So that's the external version of what we call Borg internally. It's completely different. It's re-architectured much better, ultimately, because Borg has been around for 15 years and has lots of technical debt. So basically, Container Engine is our product version of Kubernetes. So Kubernetes doesn't currently have high availability for its master, but Container Engine does. Well, to a degree. We take the master away from you, we hide it away, and we look after it for you. We give it food and water, we stroke it and treat it like a puppy. You know, stay up and running. You can see the rest of your nodes, but you can't see the master. And basically that allows you to run Docker containers. Ultimately, the Cloud Spin demo will be moved to containers because everything's going to move to containers ultimately. Isn't it, Ludo?
Yes.
Everything. And when I come back here in a couple of years' time, we'll say, you were right. So let's quickly wrap up. These are cloud platform logos. And I'm going to challenge Ludo now to tell me what each one of them is. Yeah, come on. So what is this one?
I really
Ludo?
like the original App Engine logo. You know, I still have it on my
What
laptop.
is this one? Come on.
Storage.
Cloud storage, right.
Yes.
And we talked about App Engine. We talked about App Engine.
This is the new App Engine logo, and this is the old one. Yeah.
And then also, what's this one then?
I don't know this one.
So this is Cloud Pub Sub. So the Cloud Pub Sub logo, which we use for messaging within our architecture. And then finally, we have that one?
Kubernetes? No.
Container Engine.
Container Engine, yes. And
so
then
we could have used Container Engine,
Compute Engine.
And that one is Compute Engine. And the last one is Firebase. Firebase, which we use for a coordination of the whole process.
Yeah, we can see it's a new product because it doesn't have yet the marketing.
We have so many of these now, we can't actually work out what they are ourselves. They're crazy. And ultimately, big thanks to the people who built this demo. So I really recommend you go to Google Cloud Spin and see what they produced. They're really fantastic images. And it was Brett McGowan, Frances Campoy, Kathy Cam, and Ray Zhang who created this. So really, thank you very much. We're going to take your questions. But if you don't get a chance to ask a question today or if something occurs to you later on, please feel free to tweet us. And again, my Twitter handle is there, written in my back. So there's no excuse. All right? So please tweet us, and really thank you very much for attending today. Thank you for attending Box Days as well. I'm sure they will appreciate it. Hopefully we'll come back and see you next year as well. So questions? I think they've got a system, right? So I think they've got a system for, you guys got
Oh.
No questions. Okay, right. So, okay, yeah. No. No, we don't speculate on that. So a lot of people have wondered how we do it. It's really just a case of availability. We don't go into the details of how we make it work. It's not like Glacier, which seems to be potentially Blu-ray based maybe. We do it differently, but I can't talk about how we do it. Sorry about that. So this is this in the context of App Engine you're talking about?
Or Compute Engine? Oh, App Engine.
So basically the question is, how does sandboxing work in App Engine?
Yeah, so I mean, one of the critical aspects of App Engine is the sandbox, okay? I mean, so running very quickly user code that can be anything, you know, good or bad, in a very, very secure environment, in a shared hosted environment, okay? So this sandbox is extremely critical for the success of App Engine.
Yeah, but anyway, you have to run the VM. So for every App Engine process,
So yeah, so you're talking about the new App Engine version, where the new App Engine version is running, yes, VMs, and inside this VM running Docker containers. So for this new product called Managed VM for App Engine, the security boundary is really your VM, okay? So your VM can do whatever it wants inside. You can spawn processes, eat all the memory. We don't really care because it's your VM, and this is the unit of security. You see the container, but you can still today SSH to the VM and do Docker PS and Docker kill if you want. You see both of them. You see the VM as well as the Docker environment.
Right, we have a question over here. Hey.
Yep.
Okay.
So my question is, does Kubernetes use its own implementation, so these services, or does it use a standard one? Does it have the same problems? How does it do retries?
All good questions.
You want me to take it?
Yes.
Or?
And I can answer on the registry itself. So,
So
we have a
did
product.
everybody hear the question first?
Yeah. So
Anybody
that,
not
know,
hear the question?
the-
Okay, cool.
So the Docker technology is emerging, okay, and used by more and more people every day, and it's still a bit shaky. And yes, we agree with that. No question about that. But for example, the Docker registry sometimes is not responding or doesn't scale at the Google scale. So for that, we have two things. We have created a product called Container Registry, gcr.io, which is also hosted on cloud storage.
Yep.
Interesting.
Yeah.
And it's this is where Kubernetes can host a lot of Docker images there. For managed VM App Engine, we are also serving Docker images from your project, your cloud project cloud storage. So which means that you can push very, very private Docker images without going to the Docker registry, which is public. Maybe now with security, but we are not really at all on the Docker registry for those reasons. Now in terms of, Docker containers not booting.
So let me talk about Docker containers then. So basically, Kubernetes runs Docker containers effectively. It will run other container formats in the future. So basically, there's a big movement to standardize container formats, an initiative called the Open Container Initiative, which means basically that we'll take the Docker stuff that they have, that's the underlying infrastructure for Docker, and make that a standard. Then everybody can build their own Docker formats, container formats, which comply with that standard. And then you'll be able to run any kind of container format on Kubernetes. And what Kubernetes gives you currently is the idea of a replication controller. And the replication controller will say, well, you'll say to the replication controller, this is my template for creating my containers. I want to have 5 of these, or 100 of these, or 10,000 of these running at any given time. And the replication controller will make sure that you have that many running at any given time. You have the ability to define what aliveness is when it comes to your container. I say containers, which is really pods in Kubernetes. You can say, it needs to be able to respond with a 200 on this HTTP request. It needs to be able to run this command. It needs to be able to connect on this TCP socket. So once the container becomes unlive, you'll add a new one. The replication controller will say, well, that one's gone, broken, I'll bring up another one. So that way you will manage your fleet of pods, which we call pods, which are containers inside a pod, which will do all of your work for you. Now, the whole point here is that these things will be ephemeral. They won't have any storage or any state with them. They'll have storage, but they won't have any state. So they can come and go as they please. So you can have 10,000 of them, 10 go away, you replace them with another 10. And that's the way it should work. So that will overcome some of the unreliability issues you're seeing with Docker containers. Yeah? Is that answer your question?
I agree. It's a key part of the cloud. I mean, you should expect things will go wrong.
Yeah,
okay?
so...
Docker will not start, and this is why we have those Autoscaler and Instant Manager processes capable of rebooting them.
This is a fundamental tenet within Google, is that things will fail. Machines will fail. Network connection fails. Top-of-rack switches will fail. Data centers will have their fiber connection cut. That's the whole thing, the way we work internally. We expect things to fail. And we code around that with software. And that's why we built things like Borg, our cluster scheduler, and also why we're building things like Kubernetes for other people to do the same thing. So really, expect it to fail and have more replace them. Okay, thank you. Hey, any more questions? Oh, sorry. Anybody else? Do you have a question? Oh, no? Okay. Yeah, go for it.
You said that the clients can connect directly to Firebase.
Yep.
What's the security model that enables you to do that, and how are clients identified enough to access all of the data in Firebase with only data that is intended for them?
Okay, so we have many different authentication mechanisms for Firebase. Firebase can use email password authentication. It can use a custom provider for maybe for LDAP or for Active Directory, or you can use Google, Facebook, Twitter, or GitHub for authentication. So you can authenticate users beforehand and get a token back that represents that user's authenticated state. Contains not their credentials, but information about that user. At that point, you can create rules, or you create rules beforehand that say, this user has access to this data. It can write here or it can read here. And you can do that based on parameters such as a user ID or some other kind of parameter. So you can limit the access that way. So you use rules and validation rules. And validation rules are also important as well, because you can validate the data that gets pushed into Firebase to make sure it conforms to a certain requirement. That's how it works. Okay. Any more questions before we go? Sorry? Oh,
interesting.
Hey, Ludo, just speak to Ludo. This is his favorite topic.
I mean, no comments, but I'm smiling. Yeah. So hopefully soon.
Okay, all right. One day, maybe. Right.
The reason why we are not yet on Java 8 is, I mean, really deeply connected to what is App Engine. Okay, it's only about the security. Okay, the Java 8 security model today is not good enough for us to expose it to millions of applications, but we are working on it.
All right, so there was a couple more hands. Any more questions? Anybody else does? You've had your go. Anybody else does? No? Yeah, go for it. Yeah. No, it's so we take the master away from your cluster. We create your cluster for you, and then we hide the master away from you. So the master is still the same as it would be a native Kubernetes deployment. Sorry, the question was basically the master. Is it shared, this master and container engine, is it shared between many users, or is it individual for each cluster that's created? It's individual per cluster, so we just manage it. We just take very good care of it. So yeah, it's exactly the same as a Kubernetes deployment, but we look after the master for you. One master. Yeah, there's only one master for. So Kubernetes doesn't currently have high availability for masters today, which is why we do it this way. So we host the master for you to give you that high availability, because we can do more behind the scenes than you can do yourself. So if the master does go away in a Kubernetes or container engine cluster, you still can access your data. Everything will still work, but you won't be able to create new ones. So that's the question. Alrighty, so I think we're pretty much done. Again, the Twitter path is there for you. If you have questions about Google Cloud Platform, free feel to tweet Ludo. He'll answer the question. He loves questions about Java 8 and unsupported runtimes. Ask him Java 9 questions as well, because he likes those. But otherwise, you can tweet me. And really, thank you very much today for coming. And I hope you've enjoyed everything and continue to enjoy the rest of the day. Thank you very much.